In this example, I'm going to show you how to find the domain of the rational functions. Once again, the domain, meaning we're looking for the set of x value such that our function here is defined. So this is a rational function. If you remember from chapter 3, we know we did it already, but let's go over again. Since it's a rational function, to find the domain, we set the denominator equals 0. So solve for x by -4 both sides, x equal to -4. That means our domain is a set of all value x such that x cannot equal to -4, because when x equal to -4, a rational function here is undefined, and the domain means we're looking for all the value that the function is defined and a real number. So here's our answer. Part B, we do the same thing. We set our denominator equal to 0, and we solve for x. So first, we have to factor out our polynomial. So we have x and x, plus and plus 6 and 2, because 6 times 2 is 12, and 6 plus 2 is 8. Therefore, we solve for x, we have -6 and -2. That means our domain is the set of x value such that x cannot equal to -6 or -2. This is our domain. Now, if we want to write our solution in the interval notation, the easy way is draw the real number line and mark -6 and -2. Our domain cannot include these 2 points, so I cross it out. Our domain is anything inside this interval, which is -infinity to -6. And our domain is also any number belong inside this interval, which is -6 to -2. Then our domain is any number x belong from -2 to a positive infinity. So -2 to infinity. So we put a u here, mean union. So this is another way to write the domain of our function in terms of interval notation. Let's solve for C solution. Well, we do the same thing. We set our denominator equal to 0. We solve for x. We want to know, is there any x value that will make our denominator here become undefined? If there is, then that means our domain has to be exclude those values. So I solve for x squared by -2 both sides. Then I take a square root both sides to solve for x. And to take a square root of -2, there is no real number that we can solve for x. When we're looking for a domain of the function, we're looking for a real number, not imaginary. So in this case, we only consider real number. So there's no real number. That means there's no real number in our number line that will make this denominator equal to 0. So in other words, our domain is all the x value. So this means our domain here will be all real number, because we cannot find any x that will make this denominator equal to 0. Part D, we have x squared minus 9 over 3. Our denominator here is 3. If you observe this, our denominator here does not have x value. That means this denominator does not depend on x. So That means our domain here is all real number, because whatever we put inside here does not inside our function here. That means we put inside our function here for any x value, our denominator cannot equal to 0, it's always equal to 3. So therefore, our domain is all real number. For E, once again, I will set the denominator equal to 0. And solve for x by -2 both sides. So that means our denominator here is a set of x value such that x cannot equal to -2. If we like to write our domain in the interval notation, just plot -2 here. Our domain cannot equal -2, so I cross out the -2. Our domain is any number from -infinity to -2, so here -infinity to -2. And our domain is any number from -2 to positive infinity. So here's -2 to positive infinity. And I put a union there, so that is our domain written in terms of interval notation.